What have you gotten? That's not nice. Considering what we went through. We lost 15. We just need to push. This semester, we just need to push. Usually, the only thing we're focusing on right now is school things and wise. Wait, hand over. Who said that? True. I agree. True. This one is make it or break it.
Yep. Good morning once again. I think we are going to start. Okay, however, I have some points to make before we officially start with the class. Number one, the CAT was very well done. Okay, that is good. I was really impressed, especially with the fact that I didn't see very significant cases of copying. Okay? Some questions were a bit objective, so with that you can't say much about them. But the ones that required a bit of research here and there in those questions, they were very well done, and that is recommendable. I even saw some even used some of the code that they have written for the labs to explain some of the concepts that were being asked there. Okay, so that was good. However, there is one question that was testing the psychology of people, number 5. Okay, so if you go and look at question number 5 in that CAT, what you realize is that it's a very common question in compiler design. I'm actually very sure if you are maybe copy paste that question on a Google search, chances are it will pop up. However, most likely you'll only have the answer. Majority of you only wrote the answer. Actually, of all the papers that I've marked, because I've already marked the CAT, I think only 5 or 6 people are able to explain how to achieve the answer that is there. And if you are to look at it critically, it's a very simple question because they are just asking, you can only combine two letters. Even let me break it down even to that level, right? You can only combine 2 letters, either A and B, B or C, and A and C. So you just had to explain that a little bit and you'd get the marks. So majority of you only wrote the final answer. One of you saw the answer somewhere and all of you used it. Okay, so you didn't get a mark there. I had to write for you how. So for those who did something and they were able to show the procedure of how to achieve the final answer, you can contact me later. I'll be able to give you a bonus point. That was a psychological play to see how many of you would be able to do their own work. Good. Then number 2, I'm going to give you an assignment. Okay. I think the earlier the better, instead of waiting for maybe weeks to come and then provide the assignment. I want to give you an assignment right now, maybe within this week, but then I'm going to say what it is, and then you can have an entire month to be able to do it. So you'll submit maybe there in December, the first or second week, or even maybe towards the end of the course. So it will be about solving ambiguous grammar, something that we are going to mention today, some of the techniques that you can use. And number two, bottom-up pacers. And to be more specific, what we call LR. I'll be able to give an introduction of it next week, but then I'll not go into the depth of it. So that one will be up to you. Just write something small there. I'll be able to give the specifics. Okay. Start early so that you don't have to start running with the deadlines once it gets in December. Then for the lab, I know the milestone number one is approaching. So one of you actually sent me their link to their GitHub, and I think that is the best way to examine the labs. Okay. So all the labs that you're going to do, you can always put them on your GitHub account and then just share the link. Okay. As of next week, before the class, I'll be able to share a link so that you can share whatever you've done in GitHub. I'll create something on e-learning that you can share your link for GitHub account, and then I'll be able to examine and look at what you've done. I think that is the best option, instead of you having to upload your work maybe on Google or maybe on e-learning. Okay. GitHub is okay. And also it assists you to be able to learn how to use GitHub if you've never used it before. If you have no idea how to use GitHub, just ask someone, or you can just Google and you'll find very simple step-by-step procedures of how to use GitHub. Good. With that being said, we can officially start. Okay. A small section of what you are doing, there is something we left out, which is called ambiguous grammar. But even before we go there, maybe there is a question on what I've said. Let me not think that you've understood everything I've just said. So any question? Maybe on the lab. So we are going to use GitHub, and then you just share your link. I'll provide somewhere where you're going to share your link on e-learning, and then I'll be able to see your work. The assignment, yes, I'll give an official account of what you're going to do, what is required, how many pages. Okay, and then the CAT, I'll be able to upload the marks before the end of tomorrow, but then I've already marked it. Any question up to there? Any? Good. I'll take the silence as an affirmation you've understood, and we can start here. Okay, so ambiguous grammar. So if you remember last week, if you recall, when we were doing derivation, we had two types of derivations, right? Which were leftmost and rightmost. Okay. So when we say ambiguous, we mean that we don't mean the leftmost and the rightmost derivation, as in you're getting two different pacer structures. If you remember, if you recall, before we applied precedence, there was these two. Where are they? I've skipped them. Yes, these two, leftmost and rightmost. Okay, where in the leftmost you are replacing the leftmost non-terminal, and the rightmost you are replacing the rightmost non-terminal. Okay? So in this case, even if a grammar is not ambiguous, if you apply these two, obviously you are going to get two different pass tree structures, or two different layouts of how to derive the common string. Okay, if you are trying to derive a common string, you are going to get two different structures when you apply this. So when we talk about ambiguous, we mean in this case we mean the leftmost derivation. So when you apply leftmost derivation, you are getting two different structures. And I'll show you an example what I mean. Okay, and we don't want to have ambiguous grammar when we are creating our pacers. Okay, because when you're creating our parsers, I think it's parser, not pacers, parsers. Okay, if we have ambiguity, okay, it means what that means is you are getting two different ways of expressing the same string. Okay, and that can be a bit confusing for your compiler. Okay, you need to have one common way of doing it. Okay, let me show you an example. I think an example will be better. And allow me to stop sharing for a second so that I can take a small snippet of something here that I think is very important. Okay, let me use snipping tool. Snipping tool will be better because I have an example here that I think will be better, but then I'll proceed with others. Okay, that is better. Good. Can everyone see what I have? Acknowledge you can see something. Okay, you can see something. I've just displayed a gram over there, a gram over there. So we have this grammar that is defined by these productions, okay, 3 productions, okay, and then we are trying to derive this string. So this is the string that we want to derive, okay. Now, if you are to look at it, there are 2 ways of achieving this string. Okay. One way is to use the first production, because you can see that we have a statement, and this statement can be defined by this first production. This is the first production. From here all the way to here, that's production number 1, P1, that is production 1. And then this is the second production, this one. Okay, this is production 2. Okay, so we can achieve this string over here using production 1, and then we go to production 2, or we can go with production 2 and then go to production 1. Both of them are going to give us this, okay, but then they are going to have a different structure. Okay, now we can do this together. I hope you are doing the same with me. Let me just take my annotators and then use a text. I think text to be simpler. Okay, look at this. Look at this. So if I use production 1 and then go to production 2, what I'm going to have is if, okay, if E1, okay, then S1, okay, because that is production number 1. That is production number 1. So using that, I'm able to go with production number 1. I have said if expression number 1, right, and then statement number 1, okay, that is production number 1. Then I can follow up that with the second production, where I'm going to replace now, okay, because I've already replaced this first one, okay, I'm going to replace now this S1, okay, the second statement, which is, because you're going with the leftmost derivation, I'm going to have if, okay, E1, then if, you can see I'm just following the second production now, okay, then if S1, else here, this string over here, okay, where we've used production number 1 and then followed with production number 2. The other way that we can do it, okay, and I'm going to try and use a different pen this time around, I can use red, okay, is to use production number 1 first, production 1 first. And in this case, I'm going to say if, okay, E1, okay, then S1, right, then S1, else S2. Okay, that is production number 2 first. That is the one that I've used. Then now we can apply production number 1 by replacing the first S1. So we can say if, okay, E1, and if E2, then E1. So you see, we've used, in both cases, we've used leftmost derivation because we were just replacing the leftmost statement. Okay, we started by replacing this one, and then we went here, this one the same way. But then in both cases, we've achieved 2 different structures. Okay, now this is not good. This is not good. Okay, and if you are to look even at the notes, because I know already some of you have been looking at them, you'll see that that kind of grammar, the grammar that I have here, right, is arriving at 2 different structures at the end of it all. And you can see that one even better now when you look at this diagram. Okay, so in the first instance, we use production 1 and then followed with production 2, and we're able to get this parse tree over here. Okay, then in the second option, we use production number 2 and then production number 1, and we're able to get this here. Okay, now in this both cases, right, we achieved a different structure for the same string. Okay, now this is not good. We need to have one consistent way of arriving at the structure that we are going to get when we are using one of the derivation. In this case, the leftmost derivation. It has to be 1. Okay. Now, one way we can do this is to enforce precedence. Okay, we can enforce precedence. Okay, or even in simpler terms, what you need to do is that you need to restrict or expand your grammar in a way that there is no cases of an ambiguous case, like this one. Okay, because this one is very ambiguous the way it is. Okay, one can follow this and then go to the second one. Okay, or they can go to the second one and then go to the first one. Okay, so you need to make sure that there is a way that you're restricting your compiler to start with a certain production and then follow up with another one. And one way of doing that is expanding your grammar. Okay. However, like I said, part of our assignment will be to explain some of these techniques that we use to eliminate this ambiguous grammar. Okay. So I don't want to go into too much details because that is part of our assignment. But then you can see I have an example here. So in this case, I just expanded this grammar to include the with else kind of like a terminal in this case. Okay, or variable, so that it can restrict our compiler to first use this production, okay, or even the second one, either way. But then there's this element of us restricting that a certain else, okay, only has to go with the innermost unmatched if. Okay, I'll give another example so that you can see maybe better what I mean. Okay, using that, you're able to restrict the entire tree, okay, to follow one common structure, regardless of what production you start with. Okay, I'll give you another example so that you can see how ambiguous comes in. Okay, let me go to my whiteboard. I have another very nice, simple example that maybe will be a bit simpler to understand. Consider this. Consider I have a grammar like this. Okay, I have a grammar that says S. I'm not even going to go into those details, so many details. S is given by something like S. I can use even plus S. Okay, that is one production. Or let me look for the slash. There it is. S asterisk S. Or okay, A or that is A or B. Okay, so a question here. Let me see how many are following. How many productions do I have for this grammar, for this S? How many productions do I have here? Let's see whether people are following up. Okay, how many productions do I have? In other words, I'm asking, good. So I have 1, 2, 3, 4. I hope you can see that. Okay, now just to see whether people are getting what I mean, do you think this grammar is ambiguous? Okay, do you think it's ambiguous the way it is? Because maybe that is one possible question that can be asked. And if so, how can you prove that this grammar is ambiguous? Okay, how will you go ahead to prove that this grammar is ambiguous? Okay, so what you need to check whether this language is ambiguous is to use leftmost derivation. Okay, where we are just replacing, okay, the leftmost non-terminal. Okay, okay. So to continue, I have to give you a string. So the string that I want you to derive in this case, the string, let me use a different pen. The string in this case that I want to be derived is A plus A B. Okay. So this is a string that I want us to derive. Okay. The string is this. Okay. Okay. So how can you derive this? Okay. I hope you can be doing this. Just be doing this. I see someone is asking a But then if you understood how these are 4 productions over here, right? Go ahead and try and derive this string using this grammar, okay? And I want you to tell me whether when you're using the leftmost derivation, whether you can achieve the same string using 2 different structures. If you can, then that language is, this grammar that we have over here, language, is ambiguous, okay? So for those who are maybe wondering how we have 4 productions, okay, we have to go back and try and recall what productions were. What are productions, okay? So when you're given a grammar in this case, like this one, so I've been given this language over here and I'm saying S, right? I'm just asking, right? When we are deriving this S over here, this start symbol, okay? How many options do I have to replace it with on the right? Okay, so how many things can I replace with? Okay, and we said productions are marked by these vertical bars. So what that means is when you're deriving, and in simpler terms, when you're trying to replace S, the start symbol, right? How many things can you replace it with? How many options do you have? Alternative options. Or how many forms can it take? So S can take the form of this, S plus S. It can also take the form of S multiplied by S. It can also take the form of A, or it can also take the form of B. So those are 4 different productions. If you're lost, let me show you another one. So let's take S and we say S is another grammar that is given by something like A, and then capital B, and then B, and then C. Okay, and then I go even further and I say, this A now, I'm expanding my grammar in this case, can be given by something like a small a plus B, okay, or something like that, okay? Yeah, something like that. And then finally, no, that is not a good idea. Let me just have that, and then this can also be B. And then I have something like C, okay, which is given by just the same C. So this is a capital C, and then here we have a small c. So in that case, I need a capital C here. Let me just do that, okay? So now, in this case, Isaac, S over here has only 1 production, okay? You can only replace it with only these 2. Okay, these, how many letters are they? 1, 2, 3, 4, 5, those ones, okay? However, this A over here, this non-terminal, which is appearing here so that you can replace it, has how many productions now? How many productions do you have here? You have 2 productions, this one and this one. So this vertical bar is the one that is determining how many productions you have, or how many forms can the item on the left take. That is what we mean over there. Good, Isaac. Good, Isaac. Okay, so I think we can continue. So how many ways were you able to arrive to this string using this gram over here? I'm waiting for people to tell me, and then I'll show you how many ways. So did you arrive at only one structure? Were you only able to use only one structure to arrive at this string, or could you use a different structure and arrive still at this string? Okay, just a second. Yeah, it was 5 steps. I agree with that. Okay, but what I'm asking is, okay, how many ways could you derive this using these rules that we have over here? Okay, let me go further. Good, 2 ways. Perfect. Let me explain how you can arrive this in 2 ways. Okay, let me take my text. I think text would be better. So one way to arrive at this string over here, is to start with by saying that S. I want to have that arrow S. Okay, I think I'll have to use this. So S is given by S plus S. So in this case, I'm going with production number 1. That is one way to go it. Okay, so I'm going to start with production number 1. After that, I can then say, okay, using the leftmost derivation. So I'm going to start by replacing the first S again. I don't have to use this production now. I'm going to use it the third production so that I can say that this S, I can replace it with A, okay, plus S. Okay, so in this case, I'm just deriving whatever is on the left. Okay, then the third one, I can say that A plus, okay, I want now to replace this. This is the next leftmost non-terminal S. So this next S, okay, I'm going to replace it with the first production again. So it's a bit recursive. S plus S. Okay, I'm still within the rules. Okay, then after that, I'm going also to expand again and say that this A now plus, now this S over here, I'm going to replace it again with production number 3 so that I can have A again. Okay, so you're just expanding these productions in such a way that you're going to arrive at this final string. This is the goal. Okay, that's why you often find it in some cases, it's called the goal. This is the goal that you want to achieve. Okay, so you just have to engage with these productions in a way that you arrive at this final answer over here. Okay, so yes, so I'm replacing this second S plus S. Okay, so this is the next. No, this one. Sorry. I missed a step here. Yes, this one was supposed to be multiplication. Let me just show you. This is the goal. There's somewhere I went wrong. I don't know how many of us have been able to see where I went wrong. How many of us saw that? I don't have an eraser. Good. I have an eraser. This one over here. Sorry for that. Okay. Was supposed to be A plus S. This S, I was not supposed to replace it the first production, but the second production, so that I'm able to be given a chance where I'm going to replace this input for multiplication, which is actually one of the problems that you're going to find appears with the what we call top-down path. In case you miss one production, okay, you use the wrong production, you'll have to go back, okay, and have the right production being used, okay? But we'll highlight that later. So this one was supposed to be multiplication and S there. So that when we come over here and we replace the second leftmost S, we are going to replace this S with the A so that you can align with this A over here, okay? And then we are just going to have multiplication there and S. And then in the next step now, the final step, we are going to have A plus A. And then we are going to replace this final S with the B, which is this final production, okay? So that is one way to arrive at this goal using these productions that we have here, or using this grammar here, okay? The other way is to start by saying S, okay, can be given by S using the second production. Now, you start with the second production, S, okay? And then you replace the same way continuously until the end. So in this case now, the next one will be, okay, replacing the leftmost non-terminal. This is this first one, okay? We're going to replace this S with an A, right? You want to replace with an A, what should we do here? I would like to hear some views. What did you do next for anyone? Perfect. Okay. So in this case here, this first S, okay, we'll replace it with the plus so that we can have an opportunity of replacing these two these two final goals of A and A. So here we are going to replace S with S plus S, okay, multiplied by S. Okay, so we've now replaced this with the second production. Okay, then we continue again. Okay, we start with S. This S is going to be replaced now by the third production to have A. Okay, plus S. Okay, then that. Okay, then we continue again. We start with A. That one is okay. We've already achieved the goal there. Then here you're going to have plus the second S again. You're going to replace it with the third production A multiplied by S. Okay, and then finally we are going to have A plus A multiplied now by B, because we've replaced this final S with this final production over here. Perfect, Isaac. So Isaac was actually having some trouble with productions. Now he's an expert. Good. I'm going to give you a minute to try and do the same. Okay. Just cover up what I have over here and try and show that this grammar over here, this language here, is ambiguous. It's ambiguous because there are two different structures that you can arrive at the final answer. Okay, so we wanted to achieve this string over here. There are two ways. The two ways is you can start with production number one and then continue all the way to the end. The second one is where you start with the second production and go all the way to the end. Okay, so I want to give you a minute. Try and look at this. Okay, and then tell me, if it was you, how would you compare either this or that? How would you be able to make sure that the compiler does not have these two options? It has this option and it has this option. How will you make sure that it only has only one option? Okay, so a minute, and anybody who has an answer, you can write it on the chat, or maybe you can raise your hand and I'll be able to give you a chance to speak. It's actually quite easy if you look at it. Don't put it too high on a pedestal and make it to be so big. Okay, just look at it critically for a minute. It's very simple to achieve what you want. Yes, Julie, I'll give you a chance. Just give the rest a minute, and then we'll be able to start. I see people are talking about brackets, but how can you enforce these brackets within the grammar? I do agree with that. How can you enforce those brackets? Because I remember last time we did that. A hint, you have to expand. You have to expand these productions over here. Yes, you have to expand this grammar that you have here. These roles that you have here, you'll have to expand them so that you can restrict your derivation to stick to one of the structures. Yes, so I like what some people are saying. You have to add the productions. Yes, you have to specify. I think there's a sense of specificity that is needed. Okay, because the way it is right now is too ambiguous. Okay, you can even think about the word. When I say something is very ambiguous, okay, for instance, you may give an answer and I tell you your answer is very ambiguous. Okay, what am I asking you? I'm asking you to go to the point. Okay, be more specific. So think about it. Within a minute, I'll be able to give Julie a chance to say something because I see her hand has been up for a while.
Okay, mine is a clarification. I don't.
Okay. Yes.
Okay, so I didn't get this right. So there's no point where you can start from the right.
You want to do the derivation from the right?
Yeah.
Try with the rightmost derivation. I didn't say you can do that, but try and then let me know. For this grammar, I wanted you to use leftmost derivation so that you can see that when you are using the same type of derivation, you are arriving at two different structures. That is the point I was trying to say. But yeah, try rightmost derivation and tell me whether you are arriving at.
Okay, thanks.
You start with this first production and say that S is S plus S. Okay? So in this case, what you're saying is you start with this first S. Okay, so you don't start from this side. So you can start by replacing this S with something and then continue that way until you complete. And then tell me whether you're going to get two different structures. Okay? But in this case, the formal definition for ambiguous grammar is where you have one or more leftmost derivations. Okay? So there is always a form of specific definition when it comes to ambiguous grammar where we say it's one or more, no, actually two or more. Okay, where you have more than two, or you have two, as in the minimum is two. You have two different structures or more than that. So Julie, can you activate your mic again so that I can get your student number? I didn't.
Yeah.
Good. I've seen it. That's okay. You can deactivate now. Good. Then we have Makale has something to say. Yes.
I think we could employ some form of constraint. such
Okay.
that we specify which operator goes first, like maybe multiplication before addition.
Okay, so in that case, what will you do to be more specific?
I'm not too sure.
That's okay. That's okay. Up to there. Wambua, yes. Say something.
Mine is also a question. Does the derivation
Okay.
have to be leftmost all the time, or can you start from the right? Like where you start by replacing that A times B.
Okay. 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 So they are there. I didn't get the name. Okay. Anyway, so there are two things. I hope you're not mixing these up. Okay. So yes. So the question of do we use leftmost derivation or rightmost derivation? That is something that actually we are going to see when we get into the details of pacers. You'll find that some pacers will use leftmost, especially top-down pacers will use leftmost derivation, or bottom-up you'll use this, actually a reverse version of rightmost derivation. Okay. Good. And then number two, I think the question you are asking is when it comes to these productions, right? Can I start with this final production, or do I always have to start with this production? So the question in this case is, which production do I start with? And that is the question that we are actually asking ourselves in this case. Okay? You need to find a way you can specify your grammar so that there is no level of ambiguity. Okay, because yes, the person who just asked that question, right now it's an open game. I can replace this S with an A and B. Okay, I can open with A or B, or I can start with this first one and then this one. Okay, so there is no restriction there. And that's what we are trying. We are trying to restrict our grammar in such a way that there is a level of specificity when we are trying to do the derivation. Okay. However, when we are coming up with these entire derivations, us as human beings, okay, we can be able to look at the goal, okay, and anticipate the steps that we are going to use. Okay. So if you are to look at it the way it is right now, the way I was able to derive, right, there is no exact rules that I said you must use the first production. What I told you is use these productions, okay, use them, okay, just look ahead, work with whatever you have so that you can be able to arrive to this final goal. Okay, so there is no restriction there. Okay, however, the restriction that exists that maybe I can give is the one where you look at the passes that you're going to see later. Okay, some of them will use this and some of them will use this. But then when you're trying to do the derivation, right, there is no restriction in terms of which production you can start with. Okay, and that there is what is bringing the sense of ambiguous or ambiguity in our final string that we are getting when we have that final structure. That is where that is coming from. Okay, so I hope that is okay there.
Thanks, I've understood now.
Good. Oh, that was you, Rebecca. Good. Let me give you a point. That is good. Okay. So yes. So some people are saying precedence. Yes. So actually, precedence is one of the ways that you can be able to enforce that. I don't know whether you can see what Waidaka has written there. Okay. What we call in some cases, I can see he's combined. There is the one we call left factoring. Okay. You can also use left recursion. Okay. So he's combined some over there. So what he did is that he added an extra item over there, an extra variable, okay, and then he defined it later. Okay, by doing that, you are telling the grammar, okay, or you're telling the pacer or the compiler, okay, that you can either use the first production, because that is the production that you can use so that you can get to this final answer, and then after that, you'll have now to specify A, and in that case, you'll have to go to the second rule now. Okay, so yes, so you have to add that level of specificity, if I can say so. Okay, let me allow some people into class who are kicked out. Yes. I see hand. Ryuki, maybe you can end everything for us when it comes to ambiguous grammar before I give you some questions.
And then I have a question.
Okay, ask.
What's the problem with ambiguity? See, as long as they arrive at the same answer, or
good. That means you arrived in the class late, because that was the first thing that we said. Okay. Anybody who remembers before I mentioned that? But that's a good question. Or maybe at the time the network was bad. So what is the problem with ambiguous grammar? If, by the way, that is very true, he's asking, in both cases we've achieved the same answer. Okay. So the answer lies in this hint that I can give. Okay. Put yourself in the shoes of the compiler. Okay. Or the parser. What is the problem of having these two different structures that are methods, but then you're getting the same answer? Anybody who wishes to get the points, go in once, go in twice. Okay, yes, Papa, say something so that you can get a point. And you don't have your student ID there.
Sorry, I'll change that. I was saying, in this case, the compiler realized there are two ways to get to one road. It's like a dilemma. In this case,
Yes.
the compiler is confused.
Yes.
It can get an answer in both ways. This may actually lead to an error. Since in the first one we see on the left one, used, let's say, the first production.
Yes.
Then the second one use a different production. So the production is quite ambiguous, and this can lead to like bugs and stuff for the compiler.
That's a very good answer. I don't know whether Isaac wants to expand on that. I'll give you a point there, Papa. That is true. That is true.
Hi, can you hear me?
Yes, how are you?
I'm good, how are you?
I'm good too. Okay, continue. Say something.
Okay, so yeah, so the problem with ambiguous grammar is that it has the capability to produce two past trees, like as you've seen, for one expression. And now when you get to like a compiler level, for the compiler to figure out which of the past tree is correct is going to be a really huge problem for the compiler.
Exactly. Yes.
Yeah, and as well, it can give multiple ASTs for the same string, you know. So at the end of the day, we will have conflicting like semantic definitions of elements of a language.
That is a very good answer, because I didn't even expect someone to talk about the semantics. But yes, so if you go later on and look at the meaning, which we are going to cover later on, maybe now in 2 weeks' time, right, when we come to semantic analysis, right, for these two different structures that you've seen for that common string, okay, you'll have two different meanings of it. For instance, consider that if statement, that the one that I've given in the notes, and I want you to take your time later on, because I'm not going to go deeper into that. Okay, take your time and try and read those two if statements, the two statements that have been given there, using where we first used the production number 1 and then went to production number 2, and then in the second structure we used production number 2 and then production number 1. So in both cases they mean two different things. Okay, and take your time and see that. Okay, but here I want to highlight something. So the person who asked the question, if you could kindly activate your mic so that I can see your number. You realize something. Okay, you realize something. Good, Muriuki. I have your number. Okay, so this is the reason why. So grammar is unlikely to be useful for programming language, because two structures of the same string implies two different meanings. Okay, the semantics, the meanings of it later will be different. Okay, the semantics will be very different. That is the point. Okay, so yes, we are arriving at the same answer using two different structures, and you can say that one gives us more options. But the problem with this thing is that our computers are logical. If you remember that, okay, our computers are usually very logical. This is not a human being who is doing this. Okay, you have to put yourself in the shoes, okay, okay, of the compiler, okay, and the pacer to be more specific, right? So it's going to get confused in simpler terms. It's going to get confused because it doesn't know which meaning is correct. Is it the first meaning or the second one? So that is the reason why we don't need ambiguous grammars when we are trying to implement pacers, because that is what we are working towards in this class and the next class. We are trying to build pacers for a compiler, okay, and we don't want them to be confused. We want them to know what is needed. Okay, good. I want to give us a minute while I check some questions over here that I want us to try and look at. Okay? In case you have a question, I'll be able to look at it, or you can be asking as I look for those questions. There's some questions I had that I wanted us to just look at our free time, so that you can ask yourself, is this grammar ambiguous or not ambiguous? Okay, or maybe a better question is this. Okay, I want you to design a simple grammar. Okay, even if it's going to have a minimum of 4 productions. Okay, design one that is ambiguous. Okay, and let me go back to the whiteboard so that you can see an example of an ambiguous grammar. Okay, so design your own grammar. So this is the language we have, or grammar that we have, and this is the goal as a string. Okay, so this one you can see that it's ambiguous because in both cases, to achieve this goal, we are using two different structures. Okay, so I want you to design your own, a simple one. You can even use the same structure but use different alphabets to represent the variables. That is a good example. So do that. Okay, and then after that, try and think of one that doesn't have any sense of ambiguity within it. Okay, and then we can proceed from there to talk about stop down, pacers, and we can apply some of the concepts we've learned. Isaac, I don't know whether you want to ask another question, or maybe it was from the past.
Oh no, sorry, I forgot to.
Okay, it's okay. So yes, 2 minutes, and then look at that. develop your own language. Even if you're going to use the same structure, I don't mind, but then use different variables. The reason why I'm telling you to do that is when you write it down on pen and paper, okay? And don't assume, when you write it down, you tend to remember. Okay, so do that. Do that. Even if you're just going to copy exactly what I have, but then using different alphabets so that you can see what I mean. Okay. Okay. Good. 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 Oh, I see some questions on the chat. Let me try and respond to some of them. Yes, so people are talking about precedence or multiplication. Waidhaka, I see over here even wrote an two different rules now. Okay, so in the rule number 1, you have 3 productions, but then you have 2 different rules for that language. So from John's grammar, should there be 3 productions and 1? Yeah. So that is not a problem. Okay. So in this case, he expanded the grammar or this language to have 2 different rules. Okay. But then you need to remember that there is a difference between rules and productions. Okay. So rules are this. You can see here. These are 2 different rules, if you can see that. But then for the first rule, you have 3 productions. Okay. So don't confuse that. Okay. Someone else over here, Kevin. I hope, Kevin, you can copy paste that to everyone. He's saying associativity rule and precedence. Hence, we change S to have this and then that. So write that for everyone. So what's the name of the strategy used in John's example? Yes, telling you the answer for that, Jerry, will deny you the chance to get marks in the assignment. But then I'll be able to explain later. Okay? But I don't want to give you the answers. Sometimes it's good to go and explore a bit. Okay? Or maybe even John can tell us. So John, what did you use? What technique did you use there? Because that is actually the assignment I'm asking. But then as you can see, these things are very simple. Okay? Everything about compiler design and construction is very simple because it's just about considering how the computer will look at things. Okay? Very logical, very logical. Okay? So yes, allow me, Jerry, not to say that, but then I'll be able to answer that question once we are done with the assignment. Or maybe if you need the answer, I'll be able to tell you later on, because I don't want us to have all the answers. In some cases, it's good to go and look for the answers out there. You'll tend to remember them even better. Okay, so I hope you're writing it down, whatever I've asked. Then you replace them with different characters or with different variables, okay? Just so that you can understand what I mean. Okay? Because we are trying to achieve this goal. This is the string, this is our goal. But then we are finding that there are 2 different ways you can do it. You can go with this, or we can go with this. Okay? And to be even more clear, okay, we are using the same kind of derivation. In this case, the leftmost derivation. And in both cases, we are achieving the same goal, but then using 2 different structures. There's someone who asked about rightmost derivation. I don't know whether you tried rightmost derivation and found 2 different structures, or for rightmost is giving you the same answer. Okay? Okay, so you can also try that and then let me know. But then, okay, a formal definition for ambiguous grammar is the one that you find 2 different structures or more. They can even be more when you're using leftmost derivation. That is very important because that is the formal definition that is there. Okay. Good. So 1 more minute so that we can start there. I'm also going to go and mute for a second to sip some water. Good. I want to switch gears switch gears for a second here. Let me just share the notes, the final thing, and then we can continue. Okay. So based on how you do the derivation, right? Among other things that we are going to see there, right? You'll find that in general there are two main types of pacing techniques. Okay? We have what we call top-down. Okay, top-down in the sense that we are always going to start with the root. Okay, we are going to start with the root or the start symbol, and then later on work our way to getting the leaves. For instance, in this tree that we have here, so we are always going to start up here and then get these leaves. I think that is not a good example. This is a good example. Right? So we are always going to start up here, okay, up here, and then our goal will be to finally get whatever is here at the end, because this is the goal. This one over here, okay, so that we can work that. So that is top down. Okay, then bottom up, you are going to start down here and then work your way until you achieve this. Okay, I'll be able to give an example shortly so that we can have something clearer in our mind. But then let me just complete this theory that we have over here. Okay, so at each node, the pacer will pick, or the parser that we have will pick a production, and then we'll try to match it to the input. Okay, so you can see here there's someone who asked that question. Okay, so which production do I use? You can see even the compiler, or this device that you're going to use here, the syntax analyzer, right, will have to pick a certain production, then try and match it with a certain input that you have. The input in this case are those strings, those elements in the string. Okay? So you can see that in case your language is ambiguous, right, it may find a point where it's getting two different structures and it's confused because of the meaning. Okay, then top-down syntax analyzer. Let me use the word syntax analyzer so that you can also remember that it's a different, it's another word for the same concept, right? May pick the wrong production. Okay, for instance, you remember there we had a production in the example where one was addition and then the other one was multiplication. So in some cases, it may choose the input does not match the goal that you need. For instance, you'll find that in one, for instance, in a production that has, let's say the goal is A plus A, what we had before. I hope you can see this. Okay? But then the production rules, after replacing, it finds that after going a series of steps, it finds that it has A plus B. And then instead of having a multiplication here, like the mistake I made, it finds that you have a plus again and then S. So you see in this case, okay, this production that it chose does not match whatever input is here. So because of that, it will have to backtrack, go back again to a point where it was able to replace this production here, so that it is able to replace it with the one that has a multiplication. So that is the element of backtracking, and we don't need that, okay, because it wastes our time and all that. So we'll be able to see how that is solved. Okay? Then we have the second one. The second one is what we talk about bottom-up parsers, right? Where we are going to start with the leaves and then go all the way to the root. Okay, so as input is consumed, the pacer encodes the possibilities in an internal state. So it will continuously just check those productions that you have, and then it will see what is applicable so that you can apply them. Okay? But then I would like to go even further and expand this classification of ours here, because you may find it in other literatures out there. Okay, and you may wonder where those came from. Okay, so allow me to show you something here. In case you have a question, just bear with me. As soon as I'm done with the idea that I'm talking about here, I'll be able to look at those questions. Okay, let me clear all this. Okay, so you can actually classify our parsers, okay, into two different broad categories, if I may say so. Two broad categories. Okay, two broad categories. You can have what we are calling top-down parsers. Allow me to use the acronyms here. And then you can have what we are calling bottom-up parsers. Okay? Now these top-down parsers can be classified further into two other items. Okay? We can have top-down parsers that are using backtracking. Okay, that are using full backtracking. What that means is they'll use brute force techniques. So they'll try one production, and then if it doesn't work, they'll go back. I know you're familiar with the word brute force, right? Where you keep on, it's like guessing, right? You're guessing, you're guessing, you're guessing. So you have that. So in full backtracking. Okay. And then the second one, obviously one has backtracking, the other one doesn't have. So it's TDP, top down passers without full backtracking. Allow me to use that. Without FB. Yes, that one. Okay. So here, this one you can just call the one that are called brute force methods. So here they'll be using brute force methods. They'll just be guessing, and trying to apply in a certain production. If it doesn't work, they'll go back, and then they'll keep on guessing. You can see how inefficient that is. Okay. Then for these ones, you can classify them into two as well. Okay. There are some which you'll find they're going to use what we call recursive. We'll be able to explain this one later, what it means. Recursive descent. Okay, recursive descent. Okay, they use recursive descent pacers. I know it's not very clear. I'll be able to give you a better image later on. That one. And these one are the ones that we are going to call non-recursive. Okay, so it's the opposite of this, non-recursive. And an example of this is what we call LL1, okay, which is one of the pacers that we are going to really concentrate on next week. LL1. Okay? So in this case, you'll wonder what this stands for. LL1. So the first L stands for leftmost, left to right. So the scanning of this pacer when it's scanning a certain string. So for instance, you give it a string A plus A multiplied by B. So the first L, this first L stands for the fact that you start from the left and then scan to the right. Okay. Then the second L stands for leftmost derivation. Okay. So the second L stands for leftmost derivation. That means when it's replacing and it's trying to derive to achieve to the pastry, it will start by replacing this, and then it will replace whatever that way until to the end in the production loop. Then the last one over here stands for the look ahead. Okay. So it's a form of predictive. It will be looking ahead. I think I mentioned that term as I was explaining something. Okay. So in this case, it will only be looking ahead at one element. So in that case, like one letter ahead, it will be looking at it in advance. Okay. Then you have bottom up. Bottom up, we can split them into two. We can have what we are calling operator precedence. Okay? This is one of the methods that people have said that we can use to solve precedence. Yeah. Okay. Precedence, pacers, and then on this other side, we are going to have what we call LR. You can even have, this is something like that. I can even put an asterisk there. LR pacers. Okay. What do you think the LR stands for? If LL stands for whatever I said here, what we started the left-right scanning, and then this one was leftmost derivation. What do you think LR stands for? As I continue with this classification that I have here. Anybody who thinks? And then after that, these ones can then go even further to have other types. You can have LR 0. Okay, so that means it's only looking at 1. You can also have S. Another example is SSR 1. You can also have what we call LA R, and this one goes and on and on and on. Okay. So yes, so this first L over here stands for left to right. So the scanning is still the same, but then when it comes to the derivation, we are using the rightmost derivation. Good. So a more detailed classification of syntax analyzer can be this, okay, where you're going to have top-down pacers and then bottom-up pacers. And then for this side, you can have some that are having full backtracking. They keep on going back. Whenever they guess the wrong production, okay? And those ones will be using brute force techniques, okay, which are not good. Then we have these other ones, okay? The one that you are going to find that in this case, they are going to be following a form of, it's like they are predictive pacers, right? They're able to predict what is going to happen in the next step. So because of that, they're able to anticipate the productions they are going to use. Okay, so they're able to look ahead, and because of that, they're able to get the right productions and finally get to the goal that you need. Then after that, we have bottom ups, the one that are using operator precedence. Okay, so they'll be looking at, it's like following the rule. In that they're able to follow those, and then there will be these ones on the other side. Okay. Now, one thing you need to realize is that when you're designing syntax analyzer, you can't have ambiguous grammar. Okay. So that's the reason why we need to learn what ambiguous grammar is and some of those techniques that we can use to eliminate them. Okay. Also, what's something you'll find is that this one actually is the only syntax analyzer that can be able to handle some sense of ambiguity because they're able to use the operator precedence. Okay, so if you use any of these other pacers with ambiguous grammar, there will be issues, right? There'll be so many problems there. But then for this one, because it uses operator precedence, okay, it's able to somehow handle those ambiguous grammar. Okay, we have that over there. Okay, so you can take note of that. I don't know whether if that's a good diagram or you need better, but then I'll be able to attach one which is better on e-learning. Okay, but then you can see what we are talking about here. Okay. I want to use an example of one language, and then I'll show you top-down, passing, and then bottom-up, and then we can compare the two. We can compare the two and see how they are going to look like. Allow me to clear this, or maybe I can give you a second just to look at it. And then I'll talk about top-down using one language and also bottom-up, so that at least you can have a comparison of the two. Is there a problem with the network or power today? So many people are getting kicked out of class and then coming back. If you're having such issues, let me know so that your attendance is not affected. Let me know if you're having issues. Okay. So let's start with the first one. And I'm just going to specify a small language over here, and I'm going to say S. Okay. S. S is given the small a, and then A, B, and then what can we use? No, let's keep E. Let's use that, and then we'll have A. So this one will have 3 rules. It's a grammar that has 3 rules, something like that. And then there'll be a second production here, which will have B. And then finally, we'll have the final rule for B, the capital B, which will be given by, in this case, by a small B over there. Okay. So that is it. And then for our string, the string that I want us to achieve, the goal, string or goal, in this case, okay. It's okay if you're having issues with power. That is good. It's noted. But make sure you'll check the recording. And if there's no recording that is uploaded on e-learning, always remind me, and I can be able to upload it. So that is the goal I want us to achieve. Okay. So that is the goal I want us to achieve. So I want us to use a top-down syntax analyzer and a bottom-up analyzer so that you can see how we are going to achieve that. Okay. So I'm going to start drawing a tree, and I'm going to start with the first starting symbol, which is S. Okay, so this is top, down, pacer. Okay, so it's going to start with the node. Okay, with the root, which is S. It's going to start with S. Okay, and then it's going to build 4 items, right? Because I see there are 4 items that are going to come from S. So it's going to have A, and then it's going to have capital A, and then it's going to have B, and then it's going to have E. Okay. Then next, okay, because this one is the goal, we've already achieved the goal for A. We are going to go to this second one because we are using leftmost derivation. Leftmost derivation, like we said, for top down, they're always using leftmost derivation. We're going to replace A. So what production are we going to use here? We can use the first production, okay, which is going to come up with 4 items. Okay, this one over here, and you're going to have another A, and then you're going to have B, and then you're going to have C. Okay, and then because it's just a tree, we can go to the next one. This B in itself, okay, will also come up with a D over here, but because I don't want to continue there because I want to use leftmost, I can just draw that using that production rule, and I'll be that. And then finally, this A, the final one here, is going to give us our B, so that we can have this final goal. Okay, so this is our goal. We are having this is the goal that we wanted to achieve. I hope you can see that. That is what you wanted to achieve. Okay, but if that is a bit confusing, if you have to use the normal derivation, okay, what we did to get to that final answer of this goal is this. Okay, we started by saying our S was given by A, capital A, and then we went to B and E, and then we went next. We replaced A so that you can have A, B, C, and then capital B, and then E, and then we went next. We replaced again the leftmost non-terminal symbol. In this case, we had A, okay, and then this A over here, we're able again to replace it with the B now, so that you can have B, and then these B's were still there, so B, C, and then we were able to get B, and then we had E, and then we went ahead and replaced the next leftmost non-terminal. I'm trying to follow a very nice index in there so that I had A, B, B, C, and then now this B over here, I was able to replace it with this D over here to have E. Okay. So I don't know whether you can see that. Okay. So that is top down. Okay. So we started with the root and then all the way to the leaves, to the final goal. Okay. You can see using these production rules over here, the production rules and the rules, you are able to use leftmost derivation to achieve to this final goal. Okay, we were replacing the leftmost non-terminal. Okay, now the same can be achieved for top down. Okay, in this case, let me show you how. So we can now use bottom up pacer, Just a second. So in this case, we are going to start with other root. We are going to start with A, okay, and then we are going to have B, then you are going to have B, then we are going to have C, and then you're going to have D. Let me minimize the participants for a second. Then we are going to have E. Okay. So what do we do? What do we do here? Anybody? What do you think we are going to do here? Which one are we going to start with? If anybody is following or everybody is off. I think people have gone silent. Okay, perfect. Yes, we are going to start with this here. Okay, so we are going to start with this B. Okay, and we are going to derive A. Okay. Then after that, what are we going to do? What are we going to do? Good. We are then going to combine these ones over here. These one. My internet is a bit laggy. Excuse for that. So this one and this one, because they are all leading up to something common, okay, we are going to derive them together so that they can give us A. Okay. And then after that, where are we going to go next? Okay. Just look at the rules and try and make sense out of them. Okay. Which one are we going to go next? Good. You can then go to just D. And where was D leading up to? D was leading up to what? Okay. D is leading up to a B. So I'm just going to go to this one. Okay. And this one is going to lead up to my B. Okay. And then finally, I'm going to lead up this E all the way to my S over here. And I'm also going to expand this one over here. Okay. And then this one is also going to lead up here. To make things a bit clearer, let me use this kind of derivation to achieve to that final answer. Okay, and if you are together with me, you can also do it. So that you can see. So we started by having this. We started by saying our S in this case. Having a very big problem here. Just excuse me for a second. Yes, that's okay. So in this case, I'll explain. Let me just draw it first and then I'll be able to explain. I have S and then I have A, B, E. Okay. And then I'm having A, then A, then D, and then I had E, then I'm having A, B, C, D, E, and then I'm having A, B, C, D, E. Okay. So if you look at this, Okay, what we did is we started by replacing this one here. Okay, so we started with a form of a rightmost. Okay, leftmost terminal. We started with this one, which gave us these three. Okay, okay. After that, we went ahead and then replaced this one over here. Okay, by going up still again to have these two, and then these two, which is replacing this and this. Okay, and then finally we went up and reduced these two now to have a B, and then after that you will not be examined in terms of trying to illustrate this, right? What you need to see is that maybe the explanation is not that clear. Okay, what we are replacing is we are replacing the rightmost non-terminal continuously all the way to the up to the to the root, okay? Starting with the leaves, because we started with these our leaves over here. Okay, and instead of replacing the leftmost non-terminals, we were replacing the rightmost. Okay, but then it's in a reverse way. Okay, so it's not exactly rightmost, right? Because rightmost would start up here, right? It would be us starting here and then talking about A, B, okay, and then would come and first replace this here, and then go continuously that way. Okay, so it's a kind of a reverse rightmost derivation. Okay, so that is the formal explanation over there. But anyway, the point that I need you to see here, okay, when you're using top-down syntax analyzer, right, we are starting with the root or the start symbol, and then we are building all the way to the goal. Okay. However, for bottom-up, our pacer here in this case will start with the root, okay, and then we'll apply the production and the rules that we have over here to arrive up here. Okay, I hope that somehow makes a bit of sense when you're looking at it in terms of those two different syntax analyzers. Okay, so one is where we are going up that way, and this one is where we are applying these that way. Okay, so one, it's like we are looking at the production rules and trying to see which production rules do we use to replace a certain non-terminal. The other one, we are reducing, right? So we are looking at the rules, and then we are looking at one of those symbols that we had, and we are trying to reduce it to have one cumulative one. Okay, so for instance, we are combining, for instance, in this case, this was just a bit went down, but then these ones were three of them. We combined them to have something smaller there. Okay, so that way, reducing all the way to the top. Okay. I don't know if there is a question over there. I would like to go into depth to talk about top-down pacers. So I'll switch and go to my notes. There is something small that we need to see there. Oh, I don't know. We are tired. We can have a break. Then I think it's still early. Still early. Then it doesn't hurt if people are a bit tired. Okay. People are still in class. Silence means we are okay. Good. So just repeat what I just said. Let me just repeat this, and then I can give us a short break. Okay. So for top-down parsers, as you're going to see, okay, we are starting with the root, and then we are building up to the leaves. Okay, and what we are doing is that we are constructing the root node. Okay, in this case is that S, the start symbol, for instance, in that example, and then I gave, and then continuously we'll be replacing one of the leftmost non-terminal continuously until we arrive to the final answer. Bottom up, on the other hand, is the reverse, right? So you're starting with the bottom where you have the leaves, and then you're building up all the way to the top. Okay, so I hope that is okay. We can have a short break, 5-minute break, so that we can come back and just highlight other concept about top-down pacers and see some of the limitations that they have and how we are able to solve them. Okay, so 5 minutes, then we can come back at 10:40. The reason why I want us to have a short break is so that we can end the class a bit early, so that you can have some time to do some other things, lab work and other things. So 5 minutes. Taking a production and then trying to apply it continuously. So because of this, this spacer in this case, okay, has to go back to this production here, the one that defined it as a plus. So it needs to avoid this one, okay, and it has to pick now this one. So it has to backtrack. Okay, let me go to the next slide and you'll see this. We'll go continuously until to the end. It was able now to pick that right production. Okay, let me pick my rules again so that you can see them. I want to go with these rules step by step so that you can see that. Okay, so now in this case, it was able to pick now this production, which is the correct one. So after doing that, and it went continuously, okay, it was able to realize that yes, I'm able to achieve the subtraction I need, okay, because our goal is x minus 2. Okay, but then after doing that, it comes to another problem. Another problem is found because in this case you have a term, okay, and you need to replace these other inputs here. So what will you do? You have to expand even further. You'll have to expand now the term. So what can we expand the term as? Okay, so one way we can expand the term, this term, okay, we can expand the term because you can look at the rules. The term can either be a term, okay, a term multiplied by a factor, or another production for term is slash that way is a term divided by a factor, or it can be a factor. So guess a point where it may pick a factor as a final one and it just replace it with a factor. If it does that, you realize that some of the inputs will be left out because a factor can only be one item. It can only be a number or an ID. Okay, so in this case, it must pick this production number 1. Okay, so what I'm trying to show you with this continuous derivation is top-down pacers without some of the techniques that we are going to call predictive pacers, right? Without those techniques that are going to be applied later on, it may come to that problem of having to backtrack, or you have to continuously go back, okay, to a certain production so that that production can align with the input that you have, okay? And that is the point that I'm trying to pass across here, right? So you can see at the end, right? At the end, if it chose the wrong production, it will have to keep on going back continuously until it gets the things right. And this is the thing that I've explained with all those 3 different slides over there, where I'm saying that the right productions have to be used, the right rules have to be used, okay? Because yes, you may follow the correct rule in this case. For instance, if you was to go to those rules back there, you'll find that an expression was being defined as another expression and a term, for instance, maybe a plus a term. And then there was another one that was talking an expression minus a term. So you see for this input, if you chose the first production, you'll get to a point where you cannot apply the goal that you have. So because of that, you'll have to go back in those rules that you have so that you can meet this production that has subtraction. Also, if you replace one of the items, one of the non-terminals with the wrong production again, you can come to a point where, okay, there are no options for you to replace the input. For instance, the one that I replaced with a factor, the previous slide, if you're able to see that. I don't know whether you're able to see that. When I was talking about this one up here, because we went to replace the term and then we went direct to a factor. We didn't consider that this term needs to expand to another term multiplied by a factor. I don't know whether it's making sense, right? What I mean is this. Let me just do that. Let me not assume that people are getting it. Okay, look at it this way. Okay, so until to this point where I have this final line where I'm having it's x, okay, x, then minus a term, okay, minus a term. Okay, so I need to expand this term to which item? I need to expand this term to have a term, okay, plus to have this term being, I'm looking for that line, okay, to have a term, okay, multiplied by a factor. The reason why I need this is so that I can cover these ones here. I need to have these inputs of operator being considered and also inputs of y. I need those three to be considered. However, if I followed it this other way, if I went to say and said, instead of saying x minus a hello, can you hear me? That was very bad. I had the momentum going. Anyway, let me just share that. And tell me whether that is making sense, right? So what I'm trying to show you is, right, one of the problems that you may find with top-down pacers, okay, before, especially the one that I'm talking about, the one that are applying brute force techniques, is that you'll have to keep on backtracking. You'll have to keep on backtracking. So that is one of the limitations that you'll find with these top-down pacers. The ones that do not have those predictive techniques, the ones that are able to look ahead and maybe see that the next letter is this, so because of that, I need to consider a certain production. I think that is something even us as human beings, we are doing inherently. I don't know whether you've seen that. If we are to go back even to our notes when we were trying to do these derivations, right, and we are able to achieve the goal that we wanted, whether you didn't know it, somehow you're anticipating the next move. That is how you're able to get the correct answer at the end. Okay. Even the simple example that we had where we were having a simple grammar where we have s maybe being given by s plus s, okay, slash s multiplied by s, and then this one gave us maybe another production that way, right? So for us to get the final answer, which was something like this, I hope you remember this example I gave. Okay, the way we were able to achieve this is, even though you're just picking any production at random, right? In a way, in your mind, the back of your mind, you are able to anticipate what is going to happen next. Okay, which is something that we need. But then the computer doesn't do that. Okay, so if you don't apply that facility within them, okay, they'll always have to backtrack because they'll get to a point because they'll just pick one production. And then after getting to a point, they'll realize that that production does not work with the goal that you have. So for instance, if you choose the first production, it may work, but then maybe in the next production where you're supposed to replace with a multiplication, you still use the first production again. Because of that, the compiler of this pacer that we have here will have to backtrack all the way up. That is a problem of top-down pacers, okay, the one that are not using those, in a way, look-ahead techniques, okay? We'll have to keep on going back, okay, going back all the time, okay, and we'll have that, okay. Let me clear this, okay. Another problem that you'll find with top-down pacers, if you have a question, I'll just look at it in a second, is something that we call left recursion. Left recursion. I want to give someone a chance here to get some points. What do you think left recursion is? Okay, let me finalize on this point and then I'll answer any question. Activate your mic if you have an idea. What do you think left recursion is? Because it's another limitation that you'll find in top-down pacers. Going once. Anybody? We've actually somehow looked at it. Yes, good. Yes, say something.
Can you hear me?
Yes, I can.
So I think that it's like when a string is recognized as part of the language, by the fact that it like basically decomposes into a string from the same language. on the left and a suffix like on the right.
Okay. A very technical explanation, but I agree with it somehow. Somebody with a simpler, something that can break things down. Yes, we can hear Stay, and then we can hear Isaac finally. Those three.
Okay, mine's just a trial. Since we are starting most derivation, usually the first expression is already broken down into a term. So for the consequent derivations, it doesn't change at all. So
it keeps on being the same all the time.
Yeah, it's the thing after all the iterations.
Good. Isaac, let's hear what Isaac has to say.
Okay, so mine would be like a production of grammar can be said to have this left recursion, if the leftmost variable of its right-hand side is the same as the left-hand side.
Yes.
Yeah.
Perfect. That is a very simple answer. I don't know whether some people here are reading my mind, but that is true. The explanation by Isaac is very on point. Think of this way, right? Let's say I have this grammar, or we will allow you to speak. So for instance, let's say we have this S. Okay, this one S is being broken down to another S. Okay, another S, and then maybe something like even what we had before. So you can, this is the same as this. Maybe you have a different view. Okay, but anyway, so left recursion is one of the problems that you'll find in these top-down places, where you'll find that a grammar is being specified and the leftmost variable in terminal is the same as the start symbol. Okay, because of that, when you're trying to do the derivation, you'll be put in a kind of an infinite loop where you have to keep on repeating the same thing. For instance, look at it this way. If I said an expression, an expression is given by an expression, plus a term, and maybe there are other rules. But what you'll find is continuously when you're trying to do these derivations so that you can achieve this final goal here, right? You'll have to keep on replacing the leftmost. So in the next step, again, you'll try to replace the leftmost non-terminal, which is an expression, which is again defined by the same item. So you'll come again and say an expression, plus a term. This is that, and then you'll have to add this term again. Then again, you'll go next and then define what an expression is. But then the same rule again says that you replace the leftmost item, which in this case again is this expression, and it's defined by this. So you'll have again another expression plus a term plus a term plus a term. Then you'll continuously have this infinite loop that will continue and continue and continue and continue. Even before I go further, so how will you solve this problem? How would you solve this problem? But I can give Oweru first a chance to say something. I've seen his hand has been up for a while. Yes. We can't hear you. I don't know that you are having some difficulty.
Can you hear me?
Oweru, we can't hear you. Can anyone hear? Yes, I can hear you now. I
wanted to ask about left recursion in terms of the CYK algorithm.
Okay.
Yes.
You're breaking up. I can't hear you. You're having these instances of where you're going up and then down. Can you be able to write it down? Probably you're having an issue with the network. Okay. Just write it down, but then I'll give you a point because you had activated your mic. I'll give you a point. Don't worry about that. But then just write it down. So yes, so that is a very common problem, and maybe I can let me see whether I can find a simpler example other than the one that I have here that will be able to bring things back into context. So consider, for instance, another production. Let me use another production that says maybe something like I like using S because it represents the start symbol, right? But then let me use another one that says maybe something like G, right? Consider this production. A production that says G is going to give us G and A. Okay, you say because we are using leftmost derivation, we'll keep on trying to replace the leftmost non-terminal. Okay, and when we do that, we'll keep on having these instances where we have this, and then it will go again next and have again another G and A and another A, and then again it will continue further and have another G, another A, another A, and another A. You'll be put into this infinite loop where you have to keep on continuously going that way. Okay, so one way to solve one of these problems is where you can even define another rule, and introduce another non-terminal in there. So for instance, let me clear this and I'll show you something here on the slides that I have. Okay, consider this example that I have here. Okay, where now I continuously instead of having the expression I think the network is just trying to tell us we go home, and I don't want us to do that. Anyway, so what I'm saying is, okay, one of the ways to solve this problem of left recursion that you may find with top-down pacers, because top-down pacers use the leftmost derivation, right? One of them is to introduce another non-terminal symbol, okay, so that it doesn't have this recursive. Also, the other one, and I saw someone mention it, okay, is to use a bit of a fragment of right recursion, right? So where it's like you're using the same expression, so bit of it starting again and then having plus t, right? You can have it in such a way that now it's t, right? Something like plus e. Okay, so you see when you bring it to this other side, right? You don't have that loop, infinite loop that keeps on repeating itself. Right. Also, another way is it's just a matter of expanding the grammar. That is something that I need to emphasize in this case. Okay. So when we are designing our grammars for any programming language, it's very important that you don't have these instances of people or the computer having to like try and make a decision, wondering what it has to do. Okay. You must specify each and everything. Okay. If I remember, and if you can recall, when we started talking about syntax analyzer, right, we mentioned a simple language that we had, a programming language. And I remember we highlighted some rules of, okay, that had a series of actions. And what you found is there was recursive definition. And we said to avoid instances of ambiguity, right? There should be no instances of ambiguous content within that language. You have to specify each and every item. Okay, continuously and as thorough as possible. So that's the same thing that is being extended here when it comes to the problem with left recursion, right? In the sense that we are expanding our rules so that they can cover as much items that are needed in that language as possible. That is very important. Okay? So that is a common problem there. Okay, that can be found with top-down pacers. Okay? In the sense that you can have one that has a problem with left recursion, Okay, and then the other one, you have to keep on backtracking, keep on backtracking, keep on backtracking, keep on backtracking. Okay, and maybe what can be found to be like a comprehensive solution for all this is where you have, yes, it's top-down pacing, okay, but you have a form of a predictive process, okay, where you are able to like head and see what is going to be replaced in the next step. If you're able to do that, you can be able to anticipate which production rule you're going to use. And the best example I can give you is the one that you are having here. Now, if the club knew that this operator and this operator, right, it could have avoided the chance of it using the production rule that said is being given by an expression plus a term. And then after that, it could have the other rules, okay? So if it had looked ahead, okay, it had used a form of predictive pacing, it could have seen that in the string that we have, in the input that we have, we don't have a plus. Instead, what we have is we have x minus 2 multiplied by y, okay? So that level of looking ahead is able to solve this problem of having to backtrack all the way up. Because if you don't enable that kind of technique, okay, you'll have to keep on going back every time the syntax analyzer makes a mistake of choosing the wrong production. Okay, so in that case, it has to somehow look ahead and see that the next symbol that I need to replace is maybe a subtraction, this symbol. So because of that, I'll choose a production that within it has an allowance of having a minus within it. Okay, remember, we are using leftmost derivation. Because of that, it will have to consider the next leftmost item. I'll be able to answer some of the questions that are there. Okay, I'll be able to answer, but I want to hear whether you get some of the problem that these top-down pacers will have, and the reason why we need predictive pacing. Okay, there's a reason why we need a form of, we need to be able to anticipate what is coming after whatever we have derived, okay, or whatever we have replaced. Make sense? Are we there? Or maybe I've been disconnected again. I hope people can hear me. I hope people can hear me. Good, 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 good. Okay, okay. And because of that, okay, we'll talk about predictive pacing. Okay, predictive pacing. Well, we'll be able to look ahead, and one of the ones that I want to mention, and then allow me just to mention it for a few minutes before we can switch to the labs, and maybe I can talk about something there. Right. One of the things that we are going to talk about when it comes to some of this predictive pacing is where we are going to highlight LL1 pacers. Okay, because these one are going to be able to solve some of these problems that we have. It's actually one of the most important pacers that we have for top-down pacers or syntax analyzer, right? Like I said, this first one stands for the fact that when it's scanned, it will be going from left all the way to the right. And then the next one represent the fact that it will be used in leftmost derivation. And then this means that it will be able to look ahead for one symbol. That is just one of them. Just a second. I had some notes somewhere. Let me see whether I can get. So when it comes to our LL1 pacers, there are certain items that we'll need to know and maybe have so that we can be able to understand how they work. Okay, the first item that we need is the pacer itself, right? So maybe we can have a box here that talks about it. So we'll need a box that has the algorithm itself. Okay, we'll need an LL1 pacer, okay, which is the algorithm that is going to be used. We are going to talk about it. The next thing that is going to be used by this LL1 pacer so that you can be able to see what is coming next is something we call a pacing table, which is something that we're going to look in depth in the next class. It's a new concept that I don't wish to start immediately. So we'll have what we call an LN1 base table. Okay. On top of that, we'll need a form of like a database to be able to store the items that you're going to be using. Okay. And you're going to have like a stack. It will be something like a stack up here that we are going to be using. It's like a directory that will host our things. Okay. And something you realize is we'll often use the symbol, the dollar sign, so that it can be able to guide us when a certain string has come to an end. It has come to an end. Okay. And we'll also have to use another item that we call a buffer, an input buffer. I'll be able to put this one into better context next time. But these are some of the things that maybe if you are one of those people who reads ahead, can be able to be looking at. So we'll also need an input buffer. And also at the end, it will also have a dollar sign. So this input buffer will help us know the inputs that we are having so that we can, in a way, have an order when we are trying to do the derivation. So some things that are very important in this case when we are talking about LL1 PACER, we'll have to talk about the algorithm itself. So the PACER. Number two, we'll need a pacing table. Okay, we'll also need the directory itself and then an input buffer. Okay. On top of that, we'll also need two functions that are going to aid our functions and the operations for the derivations. We'll need something that we call a fast. Okay, these are two functions similar to what you're accustomed to when you're writing a programming language, and another function called follow. Okay, I'll be able to give deeper details next time and maybe highlight what they are. Okay, so those are some of the things that we'll need so that we can understand how our LL1 PACER works. So in case you want to read ahead, you can go and look at those main items. Okay, number one, we'll need a pacing algorithm, the PACER itself. Number two, we'll need a pacing table. Okay, we'll also need a stack, an input buffer. Then we'll also need two functions, the fast and follow. Okay, using those, we'll be able to see predictive pacing that is applied when it comes to top-down syntax analyzer. So we are going to cover those ones. I think that is the end of my thoughts, not unless there's another question. There's a question such as CYK algorithm. Oweru is working really hard to get some of these points. Okay. I'm going to both answer and not answer Oweru's question. I don't know if you guys can hear me. I feel like I'm being disconnected. You're still there? Good. Okay. So one thing that I've mentioned is left recursion often affects top-down pacers because top-down pacers are using what we are calling leftmost derivation. Okay. So the question that I want to ask Oweru in this case is, you've mentioned bottom-up pacers. So I think that one should somehow answer your question. Okay. Should answer your question because remember, bottom-up are using rightmost derivation. Okay. So don't mix up concepts over there. But then I do understand some points were being hunted there. I see Miriam has a question. Yes, or maybe a comment you can ask.
Excuse me, sir. From the slides you are sharing on the top-down parser, it was saying that
I can't. Your voice is faint. Very faint.
Saying,
yes.
From the notes that you are sharing on the top-down parser.
Okay.
It was starting from level 2 and then going to level 1.
Okay.
Why is that?
Okay. Let me look at that. Let me share. So the current notes are the one that I shared last week.
The current notes.
Okay. Let me check. Is there any other question? If you have another question, anyone else, you can be asking as I check on that. Oh, where have my notes gone to? Oh, I closed them. Anyone else with another question so that at least I can answer all the questions all at once? Oh, okay, I've seen the question. I've seen now it. Okay. Okay. Let me share those notes. I think the question that is being asked is here. Good. I think this was Miriam who asked. Okay, so the levels represent the precedence. So what I'm saying is, when I say level 1, I mean, right, the precedence of this and this is higher than that of plus and minus. Okay, I don't know whether that answers your question, but that is what these illustrations means. Okay, what you're trying to do is that you're trying to establish a set of rules. Okay, that create non-terminals at each levels of precedence. So for instance, because you see, when it comes to the rules, you can't have an expression maybe without, you can't have a term without first having an expression. So that is why maybe, I know what you wanted is to have level 1 and then level 2. Okay, but then you can't have that, because in this case, an expression is being defined by an expression and then a term, that is when it comes later. But then, because we need to enforce a level of precedence, right? Okay, we need to create an non-terminal. That's the reason why we were adding this component of term, right? To create a level of term. And with that, okay, we created these different levels of precedence to show that multiplication and division, right? Okay, are in a way, I don't want to say the word greater, but are on a higher level as compared to plus and minus. Okay, that's the reason why you can see that in level 1 we have multiplication. This multiplication, if you can see, that's an asterisk there, or dot, and then we have division over there. What we are trying to do is that we are trying to add precedence, okay, and create an terminal at each level of precedence. Okay, because we have this level 1 and this other level. That's the reason why we introduced terms over here, and also we have them over here. I hope that answers your question.
Yes, it does.
Perfect. Good. Just activate your mic again so that I can get the student ID. Good. I've had it. That's okay. Any other question? Okay, so maybe I can summarize what we've done today. Okay, so we've started by talking about ambiguous grammars. Okay, we talked about ambiguous grammar. Okay, and as part of our assignment that is going to be due maybe even towards the end of the course, but I'll be able to open the research ambiguous grammar. Okay, I don't know whether there is a question like this one anyone had. What if we say that a grammar is inherently ambiguous? And even a better question to ask is, what do people mean when they say that a certain grammar is inherently ambiguous? Okay, that's a question that we can ask ourselves. That one I can be able to answer. I don't know whether I saw such a question or it's just something that I saw some. Anyway, so there is that. Okay, and then after that we went ahead and started talking about the types of syntax analyzer. Remember, syntax analyzer and the word pacers are the same thing, right? So we looked at top down and bottom up. We then used that classification tree where we had very nice examples and types of top down and then bottom up, right? We talked about on the top down, we talked about LL1, which is one of them that we are going to look at next week and look at in details. Okay, that is one of the examples that is using top down pacers and more specific predictive pacers. Okay, then on the bottom up, we've spoken about things like operator precedence, okay, and then the others, right? So the bottom up pacers are also now question 2 for assignment. Okay, so we'll have to go and look at them. Okay, so you can start be looking at those ones. But for now, before we cover LL1 pacers, so that at least you can have a starting point to do research on LR pacers for your assignment. For the week now until maybe next week, if you want to start your assignment early, you can just start by looking at ambiguous grammar and maybe some of the techniques that are used to solve. Because once you understand LL1 pacers, it will be easier to understand how LR pacers now work and maybe other subsequent pacers that are used by bottom up. Okay. Yes. So finally, at the end, we also looked at some of the problems that you may find when you're dealing with top-down pacers. Okay. Things like left recursion and also what else did we find there? The idea of having to go back. Okay, where you have to keep on backtracking because you've used the wrong production. Yeah. So I think that is a good summary of what we've done for today. Now, just a reminder, maybe for those who joined the class late. So for lab work, because our milestone number 1 for the 2 labs that we've already done, I want you to share your files using GitHub. Okay, so in that sense, what it means is you're going to upload your work on GitHub and then just share the link with me. I'll be able to create a link or a section on e-learning where you can share that link, okay, before the next class, and then you can share it there. Also, the assignment, I'll be able to upload the instructions for the assignment maybe between today and Thursday, so that you can have more than a month to do that assignment. The reason why I'm giving such a lengthy deadline is so that I don't want to hear excuses at the end of it all. Also, for the CAT, I made a comment there. It was well done, especially question, I think it was question number 2 or 3, the one that was talking about the steps, the different phases of compilers. Some people did some detailed work there. They even used some of the examples that they've done using the lab work to highlight the answers, which gave them a lot of marks. However, question number 5, very few people are able to get it, but you'll be able to see the final answer maybe later on. I'll be able to upload those marks maybe by the end of tomorrow. If there is no question, you can leave. The next 40 minutes, you can use them to go and finalize your lab work, the ones that we've done so far, and also do some research on the assignment that I've given. So today I'm not going to give you any lab because I want us to complete LL1 pacers, and then I can give you another lab work before we end. Any question? Any question? Any question? I'll take silence as an affirmation that we are okay. Good. Okay, so Gitao, maybe let me do this. I'll just upload the instructions for the assignment on e-learning. I think that is better. However, it will involve 2 questions. Number 1, the techniques for solving ambiguous grammar. Okay, and then number 2, okay, what we call bottom-up pacers. So you'll have to go and do some research on bottom-up pacers, and to be more specific, LR pacers. Okay, so those are the 2 questions that you're going to cover in the assignment. But then I'll give the details in terms of what we need to write and maybe how many pages and all that. Good. I think we are left with 5 classes until the end of the semester. I'll also give an outline as to what we are going to cover in each class. I think that one will help you prepare better. If there is no other question, the class is officially over, but I'll hang around for the next 1 more minute in case someone needs a clarification or has a question. And I hope you're using this time that I give you after the class to do the lab work, okay? I don't want to hear excuses later on where you're saying you didn't have time, you're not able to find time. There's a reason why I'm giving you sometimes even an hour to do the lab work. So go and do that. Then we can meet. Is there any other question? Oh yes, I see someone has. Okay, so for the CAT question number 5, right? If you remember, I had asked you to, I think it was about regular expressions, right? Because the previous question was talking about, the previous question was about what's a regular expression and the rules that are involved. And then the next one, you're supposed to come up now with a regular expression that defined a language, yes, that had some strings that were there, right? So what most people did is that they just gave the final answer. So they said something like, I think something like this. Okay, I hope you can see my screen. Something like this, and then maybe something like this, and then finally something like, yeah, something like that. Okay, so some people just give that answer. So that is not, and then the marks were 6 marks. Okay, so I just wanted you to explain how you're arriving at that answer. Okay, because the answer cannot just be that, and then you just leave it there and then move. If you remember when we were coming up with regular expressions, we used a series of steps, right? We had to define some items. After that, then we're able to, it's just needed to explain why the reason this is the answer. Also, the reason why I'm saying that very few people got all the marks, those 6 marks, is because it's a very common question. That question is very common in compiler construction, not only there, but also in the definition of regular expression. If any of you did automata theory, okay, all of you did automata theory because it's a prerequisite for this course, okay, that is one of the questions that probably you met, okay, and even if you even check it online, you'll probably find the answers there. So I wanted you at least to try and explain how you're arriving at that answer, okay. So the reason why I said very few people got that question, maybe around 5 or 6, is because those are the only people who explained. The rest just gave this, the final answer, and left. And then they wanted 6 marks. So that's the reason why Ian, very few people were able to get those marks. Okay, so next time, always explain, okay? Don't assume anything. The same way that we've said about, the same way that we've said when it comes to like the grammars and the languages that we are defining in our programming language, we don't want there to be a sense of ambiguous content, okay? We want us to explain each and everything. So the same way, don't assume anything. If you think something, there's an assumption that you're using, write it down, okay? Because there may be some points there for you. Yes, Julie, I see you have your hand up.
On that number 5.
Yes.
Was the answer supposed to be the only the asterisk or the plus sign? Because according to what you've written, it means you can actually have an empty set, but that was not specified in the question. So what is the answer really?
Okay, so actually the real answer, this was just a random example. I didn't say this is the exactly one, but yes. So yes, this is a closure that involves even an empty string. So did the question have an empty string? If it didn't have an empty string, then you needed to choose a plus. Okay, because this means it's at least there has to be one, okay? There has to be at least one. So in case, for instance, when I say A plus, okay, if you remember for everyone, this means it's A and then maybe A, that way. But when I say A asterisk, this means that you can have an empty string. So the epsilon, and then continue. Yes. So Julie, if it didn't have, if in the question there was no empty string highlighted, then it wasn't an asterisk, it was a plus. That is good. At least that tells me you've been reading.
Thank you.
I'll give you a point. I don't know whether I've given you a point today.
You have.
Okay, so you have 2 today. Good. I see someone else. Oh, how do you explain? Okay, I think that one I'll give it better later on because I've already highlighted it. But then there are different ways as to how you can explain that. Okay. So who is this? This is Nicholas. Allow me to complete marking the CAT and then I'll give the answers. So that at least everyone is on point. Good. Anthony, do you have a question? I see your mic is activated. Are you okay?
For the same question,
yes.
I think I know you just said that some of the things were you don't leave them ambiguous, but the question itself was kind of, you know,
ambiguous in its sense.
Yeah. So even in that case of what you just explained about if the empty string wasn't highlighted in the question, that we should put a plus. Because in the question, when I was doing this, that was one of the things I didn't know, because you've not said you have not specified that an empty string is not part of it.
Okay. I get the point you are asking, Anthony. Let me cut you short and ask you this, right? So if the question did not specify maybe the empty string was not there or not, let me ask this. Did you just write this as the final answer, or did you try to explain at least how you arrived at this? Did you try and say the question is asking us for how can I say this? It's just asking us to consider only two variables at each instance, okay, or 2 items at each instance, or did you just write this? That is the question I'm asking. So if at least you only wrote this, that is where I'm saying no. But at least if you gave a form of explanation, even if it's just 2 lines, okay. I just wanted to see if you understand. Remember, these are takeaway CAT, okay. And it's the reason why, if you remember when I was starting, I said that question number 5, I put it there as a psychological play to you guys because I knew everyone would get the answer. But I wanted to see how many are going to take that initiative to try and just explain anything. There is even someone who actually went ahead and had like an entire 10 different lines of how they derived the entire thing until they arrived at this one. Okay, so you see that is a difference. There's a difference between those 2 people. One who used a series of steps to explain. Okay, they actually says, you may know the answer. Actually, Anthony, I'm not saying you don't know the answer. What I'm saying is, how am I able to know that maybe you didn't copy that one from someone? That is why I needed that explanation, that extra explanation, or you just tell me that this is what we need to consider. This is the information we have in the question. So because of that, the only possible or logical answer to have is this. I don't know whether that's maybe put things into perspective. But then if the question was ambiguous in terms of not explaining what an empty string is, I think even that one you should have highlighted, right? Saying that the question hasn't highlighted whether we need an empty string or it doesn't. Something like that. But anyway, we'll see. If in case you'll have a problem with the marks awarded, plead your case. For the coursework, I never have issues with people having a comment about their marks. They need more marks. They felt they needed more. If you plead your case and it's okay, I will always give you the marks. Yes, Ian. I see also you have your hand up.
Good morning. So I have a question.
Yes, ask.
On number 6 in the cut.
Yes.
So if you kind of explained your regular expression, is the NFA is it capable of taking a different from the actual case that you gave, or it has to be the way you marked it according to your marking scheme? Because when I look at your interpretation of it over here in the slides, I had something similar to this, but my NFA could have taken a different form.
Okay.
Is it possible?
Let me put your mind at
different variation.
So sorry to cut you short, but let me put your mind at ease, right? So the truth of the matter is, when you're trying to, especially in anything to do with Boolean algebra, right? What you'll find is that I emphasize the method more than the answer. Okay, so more marks will be awarded to the method as compared to the answer. The reason is because of what you're saying, right? We all are not going to use the same process or methodology to arrive at the final answer. Okay, some of us will maybe put emphasis on certain rules, okay, of derivation as compared to others. Okay, so yes, Ian, if you wrote something, okay, you explained something and you derived something, and then you didn't achieve the final answer that I have on the marking scheme, I can assure you, I'll give you some points. Even for those, even someone who at least I think got something like 5 out of the 6 marks, and the reason is they actually did what you're saying. Okay, so they continuously explained their points, and then at the end, okay, they actually had a very different regular expression. But then the explanation sufficed to get all those marks because they were relating them to the question in point. Okay. Also, question number 6, I think, was the one that now you're supposed to develop an undeterministic finite automaton, right? Even that one, they even went ahead and explained how they arrived at that one. Okay? So I also give them some points over there. So yes, so if you always give explanations as to how you're arriving at your answers, okay, you'll always get some marks. Okay, so you don't have to duplicate the marking scheme when it comes to certain questions about regular expression, or even some of these other questions that you'll find there.
All right, thank you.
Okay. Ian, do you mind saying what you're saying? I see here you're saying, could I request if you require more information on that question? Okay. I think you're asking the questions maybe can be more specific. Okay, so how you interpret the question is also one of the things that is usually examined, Ian. Okay, I don't know whether you found that. I forget the book. There's a book that was written by a man. I forget the name of the book. If I remember it, I'll be able to highlight it. Okay, and they were highlighting how questions are usually examined. Okay, even at those top levels. Okay, things like SATs. I know you've heard of things like those on the one that are used in the Western world, right? And one of the things that is often examined actually is not the technical skills, because in most cases, most people know what technically is needed. Okay, but then how you interpret the question is usually what is examined. Okay, so yes, I may give you those additional information, but giving you those additional information is actually helping you get the final answer. So what I want you to do is interpret. And the reason why I'm saying that question number 5 was actually not more of an interpretation question and more of a psychological place, because it was a very simple question, because you're just told the possibilities are only 2 for each letters. Okay, so actually, even if you said that, okay, that the possibilities at each instance will only be 2 letters, that would be a very good explanation. But the problem I'm having is you're just writing the final answer. It's like me asking you, I don't know whether you remember this, maybe you're given a question. I don't remember how these questions were addressed. X plus Y equals to 5. Okay, and then another one was something like X something like minus 2Y is equals to 4. Okay, and then one person is able to do the calculation and get the final answer. Let's say that maybe X is equals to 1 and Y is equals to 3. So one person just write this final answer. Okay. And then the other person is able to show how you arrived at this. That is what I'm asking. Okay? So you, okay, but then most people just wrote this. Okay, you just wrote the regular expression. That is what is that question here. Ian, are you still there? I hope you can hear me, right? That is what I'm saying. Okay, so it's not that the question was ambiguous. What I wanted you to do is just have some form of explanation how you're able to get to that final answer. But then after return the CATs, okay, because I downloaded, okay, after I download, what I did when marking the CATs, because the e-learning, the platform that we have on e-learning is not very efficient when it comes to marking, because you have to keep on scrolling to different, what is it called, to different windows for the same person. Okay, so you have to keep on clicking and clicking. So for instance, if I wanted to mark the work for Isaac, because I see Isaac is still here, I'll need to click like 5 different windows to be able to mark all the CATs. So because of that, what I did is I downloaded all the CATs, the one that was submitted, and then I marked them. Okay, so that's the reason why I'm saying after I have uploaded the marks on AMS. Okay, if you need your CAT, okay, I think what I'll do is that I'll share all those CATs using Google Drive, and then you can just locate yours. So if you find somewhere you need more marks, and I deducted some marks without the correct way, you can always highlight it. Okay, I actually would advise you that within this time, the coursework, make sure you gain as much points as possible, because you never know what is going to happen in the exam. The exam can be very difficult, and also I'm told that it is going to happen maybe in January. You may forget some of the things in December, so make sure that coursework you get a lot of marks. Maybe to end over here before I disappear, I see someone here saying, okay, I understand. I should be helping you pass. Okay. I hear you. I hear you, Ian, and I get the joke. Yes, I'm helping you pass. That's the reason why I'm giving you very easy questions. Okay, so stop assuming anything that you're writing on that paper. Okay, always explain. Okay, Ian, that's okay. I think we can end it there, and you can have a great week, and we can meet next week. But in case you have any other questions, don't hesitate to reach me via email. Good. See you next week.